Good afternoon, everybody. Thank you for joining us on the free hydraulic webinar. I hope everybody can hear me well, and I hope that I've unmuted myself this time, because the previous time I was halfway down the webinar when I realized I wasn't unmuted. So once again, thanks for joining us. Let me just share my screen again. I'm not sure if you can still see it.
Yes, we can see it.
Okay, fantastic, guys. So as you see, the webinar will only be an hour. It will be just a quick overview of hydraulic principles, components, and just show you how we simulate hydraulic circuits. I'll quickly talk about our digital training platform, Festo Alex or Festo Learning Experience, and then we'll have a few minutes for feedback and questions. My name is Hannes Otto. I'm responsible for training and consulting for Festo in South Africa and Africa. And Charles Bond will be our training facilitator. He will show us give us a quick overview of hydraulic principles. This is really just like I mentioned, a quick overview of the hydraulic webinars. On the 5-day webinars, obviously, we will go into much more detail into the hydraulic principles. You will also get a free license for Festo Fluid Sim. Now, Charles will also show you how we will use Festo Fluid Sim to draw some circuits, to simulate the circuits, to do some fault finding. So this is really an overview and just a little teaser on how nice and how interactive these webinars can be. But we would also like you to take something from it. So there will be some discussions on basic principles and concepts of the hydraulic technology. So please, you are more than welcome to raise your hand if you do have a question, or you can just type any questions in the chat. If you have any questions, whether it's with regards to the hydraulic technology itself or any other topics that we are discussing. So please, I hope you enjoy this. There will be a poll at the end of the webinar, just for us to get some information from your side as well, whether you are interested in some of the courses that will be presenting today. So yes, without any further ado, Charles, I'm going to give over to you. Thank you.
Okay, thank you, Hannes. Welcome everybody to the Festo Basic Hydraulic webinar. And obviously, as you know, this is a free session that we will have today. I'm just going to show you a few things regarding hydraulics and what we actually do in the hydraulic course when you actually join us and see what you can expect from a course like that with us. Okay, so I'm just going to go share my screen with you. And let me see my share. Okay, let me know if you see my screen, guys. Okay, can you see it? Not yet. Yes. Hannes? Can you see my screen?
Yes.
Yes, we can.
Thank you.
Yes,
okay, fantastic. Fantastic. Okay, guys, so this is just a run through of some of the hydraulic technology. And if you have a look at my screen here, you can see that you need basic knowledge to actually be able to work on hydraulics, first of all. Because of number 2 there that you can see there, nice and nicely written, is dangerous actions cause dangerous situations and causes death, and also can cause injury to people, as well as to damage to your equipment and your machinery. So if you also come and join us on the hydraulic course, what you will learn on the basic hydraulic will also assist you a lot in actually doing troubleshooting, and because you will actually know what each valve should be doing in the circuit and how it should act, how it should respond to when you actually pull a lever, and where the oil flows, how the oil actually moves, and all the properties of the oil itself, what to look for when you actually replace your oil, and so on. So we also will look at safety all along throughout the course. The safety factor will follow you and follow us on the circuits, especially when we design the circuits, so that when you design a circuit, it will actually be safe when you want to put it together at your customer, or you want to make suggestions to your clients. So yeah, and then lastly, obviously, to take a proactive maintenance, preventive maintenance program is actually what we is why we actually would like you to do the basic hydraulics course, so that you know enough to put something together that will actually ensure that your hydraulics last for long. Okay, but we also do have maintenance courses as well. So if you want to have extra information, you can actually join us on the maintenance courses. Okay, good. Let's have a look at some of the components you will see in hydraulics. Okay, and some of the principles first, before we kick off with all the hydraulics components, is the first thing that you need to know is that hydraulics is controlling forces and movement by means of a pressurized fluid. And this is obviously what we need to start with. You need to know how to do work with hydraulics before you can actually do so any fault finding at all, because the principles actually lead you to the problem of the hydraulic system. Okay, so in other words, if we look at this this triangle that we have here, work equals force times distance. So it means that my load should move across a distance, and that means I need a force to actually be able to do that. So if I have a force that can move my load across a distance, that means I'm actually working. And now, but remember that the force actually needs pressure and area to be able to actually have that force in to be able to push it against the load, and so that the load will actually move across the distance. So if we look at there, if you look here, work equals force times distance. This is the first formula you should know when you're looking at basic hydraulics, and you need to also need to know the little triangle here at the bottom. Now, normally, if the guys did some engineering, or if you did some basic hydraulic courses on your N levels, you should have seen this at least somewhere along the line, or fluid dynamics and fluid technology. Okay, good. So if you look at the reasons why hydraulic systems fail, there's quite a few reasons why it fails, and it's important that you know these basics in order to actually preventing all your hydraulic systems to fail, and also to actually be able to troubleshoot why it failed. It's so easy to go after the symptoms of a fault or a problem that occurs in the hydraulic system, and you don't actually know what is the root cause. So the idea is that you do the basic hydraulic course, that you will have all the basic principles and understand what you actually are looking for when you see something happen or something go wrong. Okay, so obviously if you look here, you can see that oil contamination is 80% of the time the problem, and the oil temperature is 10 to 15%, and the rest of it is other problems that might even be the fault of the operator. In the case of cavitation, if you look at number 4 there, because the operator, if you do not know how to set up your system, or the technician for that matter, can actually cause cavitation, and you can create your own problems in your own systems as well. Okay, then you can also see the incorrect troubleshooting methods at the end, at the bottom there on the slide. You will see that there is quite, if you should know, there's different ways to actually go about troubleshooting. There's different methods that you can take, but you need to have the basics to actually understand the hydraulics in order to be able to do it. The other thing that you also need to look at when you're actually doing troubleshooting is you need to know what equipment you can use to find the fault, and how to actually use those, equipment that you're going to need for finding, because it's not just looking at the problem and then you know. With hydraulics, you can see nothing. I cannot just remove a pipe from a hydraulic system and then check if there is oil coming out of the pipe. That's not as easy as pneumatics. Okay, so with hydraulics, you need to know, have a background of hydraulics. You need to understand the principles. You need to know where it comes from and why that is the principle that you're going to apply to hydraulics in a certain situation. And then you need to actually form a hypothesis based on what you know. So you really need to have a background on all the basic principles of hydraulics. So it's very important for troubleshooting and to overcome these problems that you see here on the screen, which is oil contamination, temperature, oil temperature, over and under pressure, cavitation, and then also incorrect troubleshooting methods. Now, also, as you can see here, the first one, if you take the first one, 80% of the time is the oil that actually causes the problem, and therefore you actually need to make sure that you have a look at different oils and different properties of oil. We also go through laminar flow. We also go through turbulent flow, how to know when you have a laminar flow, how to know when you have turbulent flow in your systems, what can turbulent flow actually cause in your system, what happens when you have turbulent flow, and also obviously how to overcome that, and what equipment you can use to install it into your system to actually make sure it does not happen. You do not have turbulent flow and that it does not cause cavitation in your system. Okay, if you look at the next slide here, this is just some of the properties that you see there, and that we will also run through when you're actually doing a course with us, the basic hydraulics. So there's a lot of other properties as well as what you can expect from the oil, such things as things like the filtrability of the oil, also the life expectancy, the frictional resistance. So because remember, oil will flow through a pipe and there will be friction in that pipe, and the oil must be able to withstand a certain amount of friction while it's flowing or while it's moving through a valve and so on. Also, other things you need to look at is corrosion resistance and air release properties, as well as chemical resistance, and then make sure that your oil that you are using are hydrolytically stable. So, okay, but we will go through that in the course, and we will go into more details so that you actually understand all of these different types of oil properties, so that when you change oil, you actually know what you are doing and why you are doing it. Then also we will also look at some oil contamination, just also to cover what type of equipment you are using, when would you use what filters, and also how the oil should be actually be cleaned when you're actually looking at your circuits and your systems. Especially when we go into building little circuits on the basic course, we will also have a look at this and make sure that we keep in mind how to circulate oil to make sure that it stays uncontaminated by these three things. We will also cover some of the basic hydraulic components, such as the power pack, which you can see there at the bottom. There's quite a few things there on a power pack. If you do not know hydraulics, this will all be new to you already. But if you have worked on hydraulics before, then you should have seen quite a few power packs in your company or on the floor. Okay. Also, we will also go through a lot of the three different types of pumps, and we will also talk about how they actually work, how they operate, what you can expect from them, the pressures they can handle, as well as the flows. And obviously, every type of pump can do different things, and in the sense of what it can handle on a system, and have different advantages and disadvantages. Another thing that we also look at is just some of it in short. It won't be too long because we need to design some circuits. We're going to spend more time on practical, and instead of just looking at slides and going through that. We want to do more practical with you so that you can actually experience it on the fluid sim and see how the oil flows, that it makes better sense to you, and you will also build your own circuits with us. So you will follow us and we will show you what we need to see, and if when we simulate, you should simulate, and we should have the same results. Okay, so but we will go over to some of the hydraulic tubing, okay, and then also hydraulic cylinders. Obviously in hydraulics, everything in hydraulics is making use of all hydraulic systems make use of actuators, either cylinders or motors, and each you need to know actually how to control these actuators so that they actually do the work properly. So there's quite a few pressures that we need to look at when you do the basic hydraulic course. We will go through the different pressures, where you can get them, where you can set them, how to know what you actually have to set, for instance, on the system pressure. Okay. And then on the next slide here, you also see we're looking at how to tune your components. Okay, because that's part of, so in other words, how to commission your circuit. How to commission the circuit so that it actually does the job the way you want it to actually perform that function. Okay, and let's say, for instance, a clamp. So how do you want to clamp? Do you want to clamp? Is it a very hard component? Is it a soft component? If it's a hard component, are you going to clamp and hold the pressure there, maintain the pressure? And if it pushes back, if there is some back pressure from the component side, do you mind or do you not mind? How are you going to prevent that back pressure from destroying the component? If it's a softer component or if it's a harder component, how can you maintain that pressure there? Okay, so we will look at different things, different valves, how you can control the circuit that you're actually designing and putting together so that it does exactly what you want it to do without damaging your components. So we will do practical circuits that has a practical application in industry. Okay, then we also go through some of the valves. This is obviously, you can take a picture now of this slide. It's a good thing to take it now. I'll quickly show you what some of the valves look like, but we will go through this, the number of the ports, the position of the valves, the condition of the valves you can find valves in, a method of actuation, the method of reset, and the port size. Normally port size in the fluid sim, we won't use port size. Obviously, you do not have the actual valve in front of you, so you will just use number 1 to 5 when we do the course. Okay, then we will also go through different overlaps of the valves, the different valves, the 4 three-way valves. So that will cover different types of overlaps that will perform different functions in a hydraulic circuit, and why you would choose one overlap over another overlap. Okay. Some other things that we will also cover is just some of the basic rules. You can take a picture of these 6 basic rules. So before you come to the course, you should know this at least to be safe, just when you design your circuits on your fluid sim and enjoy the course. Okay, so just remember these 6 things. This you can take as a good knowledge home with you now, because we only have an hour. We can't spend too much time on it. And I quickly want to show you some simulations we will also go through or make use of to actually indicate how valves work and how they actually operate, and how the operation runs. Let me quickly show you. I'm just going to bring in there we go. There's one of our simulations. So this is actually a 4 two-way. So if you know how to name a valve, you will understand what it's actually all about here. But let's quickly have a look at what's going on the valve here. So here we have a pressure port, here we have an A port, the B port, and the tank port. So T is obviously the tank, B is the pressure, A and B is our working lines. So the A and B will be your outputs. The P will be the main pressure, and T will be your tank line. So if we play it here, simulate it, you can see that when we start to push this button that we have here, we're blocking A, and we're actually blocking B as well. And that's now while we are pushing the button. So let's have a look. If you push it further, we actually see that we connect B to B. So the oil comes in at B, it flows back to B. So the working line B will be active now. And A, the working line A, will actually return all the oil back to tank. There we go. So I'll just take it back again. And let's see that again. So first of all, in the moment, we got B connecting to A and B connecting to T. So there you can see B goes to A, connected to A, so the oil can flow this way, and B connected to T, so the oil can flow that way as well. When I push the button, there we go, and we fully push it, there we can see that we actually connect B to B and A to T. So in this case, this valve could serve as a directional valve. Okay, so a directional control valve that you can use to make, for instance, move a cylinder forward and move a cylinder back. So A and B would basically be on your cylinder. Your power pack would go to B, and your tank would be obviously be connected to T, so that you can always return oil back from your cylinder. Remember, in hydraulics, oil must always be moving. It should always go back to tank. If you block anything on any line in a hydraulic system, and you do not have safety on that system, there's something will happen, and what that will happen is something that will break. So if your pump is not as strong as is the weak point in the system, your pump will break. If your piping is the weak point, then your piping would break. If you have anything else in that line, whatever is the weak point in that line will actually break. First, when you overpressurize a line. So when you overpressurize a line, it's not good practice. It should never happen. And we also show you on the basic circuit and on the basic component, course, how to actually use the circuits and the components and combine different circuits even to go towards automation. So you remember, you always need basic components to form basic circuits. When you have basic circuits, you can combine basic circuits to give you basic systems. Okay, so it always has to build up. But you need to know the basics. That's where it starts. You need to know how your valves operate, how they perform, what you can expect from them, and what to look for when you actually also have to open one up and do some fault finding and troubleshooting. So we go through all of those type of things in the basic course as well. Let me just show you another circuit here. I'm just going to get one. Have a look over one here quickly. There we go. So this is just another one of the principles of hydraulics, just to show you that hydraulics oil cannot be pressurized, but compressed, but it can be pressurized. So you can pressurize oil, but not compress it. It's unlike air. Okay, so it's not the same as air. So if anybody ever told you that hydraulics and pneumatics operates the same and is the same thing, it's not true. Okay, with hydraulics you can die. With pneumatics, maybe you pop an eye out or something, you know, because the pipe is going hitting your eye, and you know, I don't know, something goes wrong because you are not holding the pipes while you're unplugging it. Well, there is pressure on it. But when you unplug a pipe on or disconnect a pipe on a hydraulic system, while there's pressure, you may die. Okay, so it's definitely not a joke. You need to know the basics regarding hydraulics. Let me also bring up quickly FluidSim just to show you about FluidSim, what that looks like, and how we can actually also make use of that. Okay, so this is FluidSim. We will not be using the pneumatics and also not any electrical here on the basic course. We will purely focus on the hydraulic components. Okay, so if we look here, if I bring in some, if I open up the actuators, you can see we have some actuators here. We will have double acting cylinders, single acting cylinders, and then a range of other different type of actuators that can be used. Okay, I'm just going to open up my new blank screen here. And what I'm going to do quickly is just to extend my size of my screen, or my drawing screen. So I'm just going to make this 500, 500, and so, okay, there we go. So now I can play on the white canvas here. So very easy to show you, just to show you how the FluidSim operates. And very easy to follow us when we actually draw some circuits together on the circuit, on the basic course. You just click on any of the components that you want, and you're can then just drag it in. So you click on it and you drag it in. And I just want to open quite a few here. There we go. Let me just close here. Okay, there we go. And yes, there we go. So you can just click and drag. And let's go to supply elements. I click and I drag. Let's go to another one. There, click and drag. And let's go choose a few valves for ourselves just to build the basic circuits, just to get something running. Okay, we have some gauges. You can join, bring in some gauges. Let me bring in 2. We can then also add some valves. So let's add some pressure valves. So there's a pressure relief valve. We can also do this to your components if you wanted more than one, if you didn't want to drag them in. I'll show all of these things to you when we actually build the circuits together. Okay, then you can also add some directional control valves. I'm going to bring one of these in on purpose, then we can change the valve to actually what we want to see. So what we're going to do is quickly build this basic circuit. Let me do that. Okay, there we go. So what I want to add to my circuit here is obviously you cannot just switch on a pump and then just operate your cylinder. It does not work that way. Okay, we want to be in control especially because of the unsafe conditions that can arise if you are not controlling your hydraulics properly. So here on the side, I'm just quickly connecting a system pressure valve. This will be a pressure valve, pressure relief valve that will be used as a system pressure. And I'm going to connect the gauge there to monitor that pressure as well. And here on my line, I do not want the oil to flow directly to my cylinder. What I want to have is a control valve in between to be able to control my cylinder. So there we go. So now we have a nice and easy circuit there, but we need to add the tank. Remember that oil must always return to tank. So you must have a tank. The oil must flow into the circuit and always back out of the circuit again. So let me quickly click on this, double click on this valve here. You will see once you double click on a valve, it will open up. You can go to configure valve here, and then you can actually do some work on it. So I want a lever, and I want the lever to be latching. So I'm going to put that there. We can put springs, but I'm not going to put a spring in this case. I want it to stay in position. Here we go. Then you just say, hey, okay. And there we go. So now we can control our circuit. Okay, what I want to do is we can just put a gauge here, somewhere, anywhere. Just remember the gauges you can put anywhere on the circuit, and you can have as many as you like. Okay, because it's just your eyes. Remember with pneumatics, it's easy. You unplug the pipe, you check, there's air there, and you can put a gauge on it, connect the gauge, and see what the pressure is while it's still in your hand. But with the hydraulics, you can't. You need to know what you can do is you can have some plug points at different points on the system, and you take your gauge and plug it into different points and check the pressure that way. Okay, but anyway, this pressure, you will see that the gauge will show something, that gauge will show something, and this one will show something once we simulate. Okay, so there we go. So there we go. And okay, there's some warnings. The warnings it's talking about is that this tank is open. I didn't use this this pipe going directly into my tank line. I didn't want to do that. I wanted my own tank lines to be added. Okay, so at the moment you can see we have 35 bar. So if I click here, you can see this actually set to 60. Okay, so that's the question is why? Why do we have a 35 bar if it's set to 60? So this pressure relief valve does a different function than this one. If I click on this one, you will see we have a 29 bar, and we can play that. That will change the system pressure. Like I said, this valve will be for system pressure, and the other valve will be actually if I just move this out of the way, this valve will be to protect your pump. So one valve is to protect the pump, and the other valve is to protect basically your system. So what we can do now, after I did that, I can actually move my cylinder. And if I go, there we go, and I can move it, you see? And you can see the pressures, there we go, 48 because that's my system pressure. This one is still set to 60, so if this pressure valve fails, let's make it fail. Let's set it very high. If that one fails, what do we get? We get this around 60 because of friction on the inside of the parts. We have a 60 bar instead of a 60. So it's a little bit higher than what we set here. Okay, so there we go. So this is just a basic circuit, just to quickly show you some of the components in use. Okay, and there I can see I can move forward and backwards. Okay, and if we quickly want to compare this valve to what we said earlier on regarding our regarding the slideshow, if I go here again, there we go. If I go here, and I want to bring in my fluid sim as well. Let me make this one smaller for you. There we go. Just try to track it in. It's a bit big at the stage. There we go. Okay, so here we have a little circuit, and there's some explanation regarding my valve here. I can also zoom in on my valve if I wanted to. On fluid sim, I will show you how to do that as well from the basics. So here we can see here's a valve, and we need to name this valve. So let's quickly name this valve according to the steps here that I've got here next to my valve. Okay, so the number of ports is now first of all that you need to look at. So how many ports do we have? We have P, we have A, we have B, and we have T. So that's 1, 2, 3, 4. 4 ports, and that is the 4 ports. That is for number 1. So now you can write down number 4. Okay, so how many positions does the valve have? Let's have a look. Okay, here's one square here, and there's another square there. So that means there is 2 positions. So the valve can either be in this position or in this position. Okay, so that means it's a 2-way valve. If we're looking at number 3, what is the condition of this valve? Now, normally you can have valves that look like this as well. Let me open up here. Okay, so it can be looking like that. It can also look like that. Let me take this away, make some space. There we go. So put that one there and that one there. Okay, so here we have a different valve. Here we have a different valve. But looking at these valves, let me change this one quickly just to show you what a normally open would look like if I had to give it the name of normally open. So I'm going to change that to there, and I'm going to change the 2 overlaps. the two positions on the valve itself. So now you can see P is open to A. So that would be the condition for this valve would be a normally open valve. This valve, if you're looking at P, it is blocked. So we always look at pressure. Where does pressure go? If P goes through, it's a normally open. If we look at P here on this valve, it goes nowhere. That means it's normally closed valve. But what about this valve? If we have to simulate the circuit again, if we look at it here, then you can see it's already open to B. But if I pull the lever, it's open to A. So what on earth are we going to call this valve? Because it's not normally closed. It's not closed so that it can open. It is already open. It stays open. Doesn't matter which direction I go. Yeah, if I push it there, you can see that P is closing. That means it's a normally open, wanting to close. So if I let go of the lever and I return it, it opens again. So this is not the same as any of these two valves. So here we have a normally open valve, here we have a normally closed valve. But this cannot have the same name as any of these two. This, in actual fact, is called a directional control valve, because you have two outlets, and you can choose where the oil should flow into and where the oil should flow out of. Okay, so what we're doing here is to change the direction of a cylinder. Let me say quickly, you can do this as well. When you join us, you can say fit to window and the view, and there we go. Okay, so there we go. You can see this is a directional control valve, not a normally open valve or a normally closed valve, because it's always open to somewhere. P goes to B now, and here P goes to A. Okay, and there you can see our circuit is simulating. And some additional features that we can do on the simulations when you actually join us for the course is you can go to tools, you can go to options, you can go to simulation and add slow motion factor. So if the circuit runs too fast for you and you cannot keep track of what should happen and what is happening, then you can run it in slow motion to see how is the oil flowing through my valve and into my cylinder, and how's the oil flowing out of my cylinder. And if you add other components, what's that other component also doing in that circuit? So there's a lot of things we can explore while we are working on FluidSim, and we will definitely be exploring different circuits. We will always start with a basic circuit, and then we will go to larger circuits as we progress through the course. Okay, so let me just also show you this. We can also add libraries when you join us on the course. We will also show you that you can add libraries and how to do that if you wanted to create your own library on the FluidSim. Okay, so let me bring in some hydraulic circuits. Let's quickly look for one that I can show you here. Okay, seems like I've missing it here. Yeah, but it here. Okay, but anyway, this is just to show you. You can, if once you have the circuit ready and you have already joined it, you can, once you join it here, you can click it and drag it back into your library. Keep it there and leave it there. If you want to bring it back out, you can just click on it and bring it back out. And there we have it. There's a basic hydraulic course, a basic hydraulic circuit. So let me quickly do this and bring it back into the window. Window. There we go. So here's some electrical. There's some hydraulics. There's some differences between electrical and hydraulics. So there you can actually now simulate it and see what it does. So if you do, if you come back and join us for something a bit more advanced on hydraulics online, then we will also add some electrical control. So you can see there's a lamp, there's a button, and your power supply. And here we have the power pack and the motor and our valve. And you can see this valve comes back by itself because there's a spring here and it pushes it back to the valve back to its original position, the home position, once I let go of the lever. So as long as I hold it, the motor will turn. And when I let go, the flow will stop and the motor will stop as well. Okay, so we will definitely be covering a lot of components and a lot of circuits in the basic hydraulics course. But the main thing is that you need to understand, when you do the course with us, the main thing for us is that you understand what you're actually doing and why you are using those components and where you are putting them and why you have them in that circuit. Okay, let me quickly show you also some other So another circuit that I have here, just to show you also, we will also share some circuits on this and simulate them by simulations itself, not on FluidSim. For instance, this is now going to lift, it's going to lift a mass, and then we're going to bring the mass back by releasing some of the pressure. And at certain points, using specialized valves. And once the valve is activated, the cylinder can return. And we will go through these types of valves and different valves, what you can use to do perform different functions, and what it will be used for. Hannes, I'm not sure if there's anything you want to add to the FluidSim at this stage.
Thank you, Charles. No, I don't think there's anything that we would like to add. What I would like to mention is that FluidSim, as you saw now, is what you will be using. Each participant on the 5-day webinars will be receiving a full FluidSim license. The exercises that will be done throughout the course, you will do on your own. So that's why we really call it the practical webinar. So you will take part in the practical exercises on the 5-day webinars. Now, I'm referring to 5-day webinars, but it's only 2 hours per day because I know that it could be quite taxing to sit behind a computer screen the whole day. So it's only 2 hours per day, but you will then perform your practical exercises on FluidSim, and at the end of the course on the Friday you will receive an assignment and complete the assignment also on FluidSim. Return that back to the facilitator, and depending on let's say the facilitator is Charles, he will then mark the assignment, and depending on the performance or how you did on the assignment, you will receive the certificate on the webinar. So Charles, thank you very much. Guys, are there any questions with regards to hydraulics or what Charles has shown us here? You can just type in or just raise your hand and I can unmute you. If there isn't any questions, I would just like to go through just some other blended learning opportunities. So I'm going to share my screen with you guys. Let me just get the presentation up here. Okay, Charles, so just please tell me if you can see my screen.
Yes, I can see it.
All right. So we talk about Festo blended learning. I'm sure that all of you have heard about blended learning before. Now, the blended learning that we can offer are the face-to-face training courses. I'm sure that all of you would know about the face-to-face training courses. The interactive practical webinars, which is what Charles showed us now. So that will, like I mentioned, be really interactive. You will be able to communicate with the facilitator while he's presenting. You will be able to ask questions. You will simulate and design on your side while he's doing it on his side. So it's really as practical as it can get, especially under the current conditions. And then also our online training courses. So if we look at the face-to-face training courses, you know that we've got technologies like pneumatic, hydraulic, PLC, which would cover codices as well as Siemens, electric automation, process automation and water treatment, and robotic and mechatronics. Now the face-to-face training courses, obviously, there's maximum interaction. I mean, you build the physical components, you use the physical components to build the physical circuits. So there's maximum interaction. A lot of hands-on experience. So you will build the panels, you will use the components to build the panels, as you can see on the right of the screen there. And the courses are also CPD accredited, some of the courses. If you look at the interactive practical webinars, like the one that Charles showed us here, like I mentioned, there's interaction with a facilitator. It's live. It's not something that you look at a recording. It's a live webinar. There's practical design and simulation on FluidSim, as Charles showed us. It's a safe environment, especially under the COVID conditions, and it's really cost effective compared to the face-to-face training courses. Also, those courses are CPD accredited, which will mean a lot if you're registered. Right, so the technologies that we are covering on the practical webinars are pneumatic, which covers the basic and electropneumatic, hydraulic, as well as PLC, which will then cover codices as well as Siemens trainings or webinars. The newer platform that we have is Festo LX. Now that is purely online training courses, LX or Festo Learning Experience. The courses that we cover there are electricity and electronics, fluid power, in the Internet of Things and Industry 4.0, factory automation, electric power technology, metalworking, process automation. And I will expand a little bit just on Festo LX, just for because it's quite new and just to make you more comfortable on what Festo LX can offer us. Now, Festo LX is a cloud-based training. There are over 200 courses to choose from. Very economical and convenient, so you can do it on your own time, whenever, wherever, on whichever device you want to do it. There's customized content and learning paths. So if you or your employees in the company, if they are fitters, then you can go more mechanical. If it's instrumentation, you can go more electrical. If it's maintenance, you can do a blended learning of or a blended combination of fluid power, hydraulics, pneumatics, electricity. Like I mentioned, it's self-paced, so you can decide when you want to do the courses. There's progress and result monitoring. So if you monitor the result of your employees, you can see exactly where they are, what the progress is on the courses or on the allocated courses, and you can assess them if there's anything that they need assistance with. And then, as I mentioned, multi-device participation. So either on a cell phone or a tablet or a laptop or a PC, depending on what is the best way for the employees or the students to run this online trainings. Now, how does Festo LX work? Festo LX is bought in packages of 25 licenses. You will have an administrator, which will probably be your training administrator, your training manager, and you will create courses. Now, you can either make use of the existing courses in Festo LX in the database, which I will show you just now, or you can create your own courses, add nuggets onto existing courses, or take nuggets from existing courses and put that together to create a new course. You will then assign the courses to the participants or to your organization. Like I mentioned, some of the guys might be instrumentation, some might be mechanical, some might be maintenance, some might need soft skills. So you assign different courses to different participants. And then they start learning, work on their own course wherever they want, whenever they want. You can even integrate animations, videos. They can upload videos of exercises or projects that they've done. They can upload it into the cloud for the rest of the groups or the group of or the rest of the people in that specific course to have a look at. And then also monitoring progress and support. At the end, there are assessment for the courses, and really successful return on investment on what the guys have learned. So we can have a look at some different ones. There are standalone e-learnings. So that is what you will do if you do not have any components or if you don't have any equipment. There are eLab courses. eLab courses are specifically for those customers who already have Festo learning systems and training labs. So you can say exactly which training lab you have, and the courses would then be configured according to the components that you've got. And then there's evaluation. And as I said, there's a lot more than what we can discuss and what we have time for now. And that's at approximately 1,600 Rand per license per year, and with a package of 25. The nice thing is that if you buy 25 licenses, you can reallocate those licenses to different employees or different people in your organization. So that those licenses can be used over and over, those 25 licenses. And there's not a limit on the number of courses or the type of courses or which courses you can do. What I would like to do now is quickly show you just on the website itself what Festo Alex looks like. So this would be the website. This would be the platform of Festo Alex. If you go on search, you will see that, just want to confirm, can you still see my screen? Can you still see Festo Alex?
Yes, we can see it.
Okay, fantastic. All right, so we can see that there's electricity, electronics, there's fluid power, there's Internet of Things, Industry 4.0, factory automation, electric, metalworking, renewable energy, there's process automation, even communication and radar technology, logistics. So this would be more your soft skills, organization and people. I would like to have a look, and let's see if we look at something like a basic hydraulic circuits. So there are the learning units, basic structure, control, design, components, additional operating conditions. You will see that the total learning time for this particular course is 1 hour. And if we look at the structure, then we see that it's basic hydraulics, basic structure of hydraulic circuit, the control of hydraulic actuators. There's a single acting actuator, normally closed, single acting, normally open, directional control valves. So this is the structure of all the courses that we have. And as I mentioned, there are over 200 courses that you can look at without needing any equipment. So this is really something that we encourage our customers to look at. It is extremely economical for you to buy, and the amount of courses and the amount of knowledge and the amount of skills that you can transfer to your employees or even to yourself is just remarkable. So are there any questions with regards to Festo Alex? Charles, I can't see the chat at the moment, so if there's anything,
There's nothing yet, Hannes.
Okay.
Nothing yet.
Guys, if you don't mind, I'm just going to launch a quick poll. So that poll will cover the 5-day webinar, Festo Alex. It's just 3 questions. If you don't mind just completing that poll for us, I will give you some time. Once again, if you have any interest in this, you're more than welcome to contact us, contact Festo, contact your sales engineer. Charles, just want to make sure if you can see the poll.
Yes, I can see it.
Okay. All right. Yes, there the responses are coming in. So guys, this is really, as we mentioned, a blended learning. So we have the face-to-face training courses. We have the webinar, which is very interactive. And then we also have the online trainings. So it doesn't matter what the situation is. If you don't want to do face-to-face training courses, there's also the other 2. For Festo Alex, that can be combined with face-to-face training and the webinars, and the value that you get for Festo Alex is really very, very good. All right, I'm just going to give another 30 seconds or so for the poll. Okay, guys, so what we've showed you today is just really a teaser, just some basic principles on what basic hydraulics is all about. As Charles also mentioned quite a few times on the more advanced training course or on the 5-day webinar, we will go into detail. According to me, hydraulic training is one of the most important aspects. If you do have hydraulics in your company, it is very powerful, therefore it's very dangerous. It can, as Charles also mentioned, it can damage your equipment, it can damage the hydraulic components themselves, and it can be fatal. So please, if you do have an option, start with hydraulic training, attend our face-to-face training courses, attend the webinars. Yes, and if you do need any information, you're more than welcome to contact any of the sales engineers or myself, and we can most certainly put you in contact with the correct people, or we can give you the information that you need. All right, guys, yes, thank you. That is 8 minutes before the time. If there are any questions, you're more than welcome once again to just to raise your hand. We can unmute you. But other than that, thank you very much for attending. Thank you for your time. And I hope that you got something from it. I hope that there was some value add to the short webinar. And yes, remember there's a PLC webinar that's coming up next Thursday. If you are interested in that, we will be sharing some of, or the same registration form. You can just register on the PLC training as well, and we will send you the invite on that. So thank you very much. Thanks for attending, and have a great afternoon.
Thank you. Bye-bye, everyone.
Thank you, guys. Bye-bye.
Thanks, Anas. Cheers.
Bye, everyone.
Cheers, everyone.